Bismillahirrahmanirrahim. Today we are going to speak about the right triangle trigonometry. We said that a triangle is a right triangle if we have one of its angle is 90 degrees. So we call it right triangle trigonometry. So in this given figure, I have two triangles and we define one of the angle to be theta or beta. For if we define one of the angle theta, then we have two sides to be defined as or as the adjacent. It means it is the line or the side that is close to the angle. We call it adjacent side, this one. And we have opposite side. So we have adjacent and we have the opposite. The longest side or the line or the side that is opposite to the 90-degree angle is called the hypotenuse. So we have opposite, we have hypotenuse, and we have adjacent sides. Now if beta given to be defined in the other corner, then the adjacent, it is with the same definition. It is the side that is close to the angle. This is the adjacent in that case. And the opposite side, and we have the hypotenuse is the longest side or the largest side of the right triangle. So these are the three sides for the angle. We have opposite, we have adjacent, and we have hypotenuse. Now for any two sides, we can create a ratio. So from these three lines or three sides, we can create 6 ratios, and these ratios we define to be something called the trigonometric functions. To define this one, let theta be an acute angle of a right triangle. We said that acute angle means less than 90. So we are speaking about the acute angles of the triangle, either this one or this one. We are speaking about the acute angles now, less than 90 degrees. Now the value of the 6 trigonometric functions of theta are given. We have 6 ratios with these 3 sides of the right triangle. The first one, it is sine theta. We call it sine theta. And it is defined to be the length of the opposite side divided by the length of the hypotenuse. Again, for the sine theta, it is the opposite and the hypotenuse. Opposite divided by the hypotenuse will be defined to be the sine theta. Cosine theta is the length of the adjacent side, this one, and the hypotenuse. It is length of the adjacent side divided by the length of the hypotenuse. For the tangent of theta, it is opposite divided by the adjacent. Opposite divided by the adjacent. Cotangent theta equal to the length of the adjacent divided by the opposite side. And you can see tangent and cotangent. Cotangent can be written sometimes as 1 over the tangent. You can see from the definition that the cotangent is the reciprocal of the tangent. If we just write it upside down, we will have tangent, or if we reverse the tangent, I will get the cotangent. Secant theta equal to the length of the hypotenuse divided by the length of the adjacent. See this one and cosine. They are the reciprocal of each other. So secant can be written as 1 over cosine theta. And cosecant theta equal to the length of the hypotenuse divided by the length of the opposite side. And cosecant and the sine, they are the reciprocal. So this will be 1 over sine theta equal to the cosecant. We read this as cosecant of theta. So these are the 6 trigonometric functions. If we have acute angle, we have right triangle, we can find the 6 trigonometric function of given theta. For example, suppose that we are given this example and we need to find the 6 trigonometric function. Or even this abbreviation for the trigonometric function of theta. Suppose that we are given right triangle, and this is theta. Suppose that we are given the adjacent of theta equal to 4, and the opposite is equal to 3. And we need to find the 6th trigonometric function, which means I need to find the sine, I need to find cosine, tangent, cotangent, secant, and cosecant. But from the definition of the sine, it is the length of the opposite divided by the hypotenuse. Now for this theta, this is the opposite. So this theta, this is the opposite. But the hypotenuse is not given there. Hypotenuse is not given. Since we have a right triangle, then we can use the Pythagorean theorem. For the Pythagorean theorem said that the hypotenuse multiplied by or equal to by the using, or let's say by Pythagorean theorem which said that the hypotenuse equals the square root of the opposite square plus the adjacent square. The Pythagorean theorem said that the hypotenuse equals the square root of opposite square plus adjacent square. And we have the opposite equal to 3 square plus 4 square. This will equal to the square root of 9 plus 16, which is equal to the square root of 25, is equal to 5. So the hypotenuse is equal to 5. Now I have the 3 sides. I have the hypotenuse, I have the adjacent, I have the opposite. I can find the 6th trigonometric function. Number 1, sine theta equal to, it is the opposite divided by the hypotenuse, which is equal to 3 over 5. Opposite 3, hypotenuse equal to 5, it is this one. So the sine theta equal to 3 over 5. Number 2, cosine theta is equal to the adjacent divided by the hypotenuse, which is equal to 4 over 5. Number 3, tangent of theta equal to opposite divided by adjacent, which is equal to, opposite is equal to 3, adjacent is equal to 4. So it is equal to 3 over 4. So the value of the tangent theta equal to 3 over 4. Number 4, cotangent equal to the opposite of the tangent, which is the adjacent, divided by hypotenuse, and this will give me 4 over 3. Number 5, secant theta is equal to hypotenuse divided by the adjacent. And this will give me 5/4. Go back. Adjacent is equal to 4, this one. So the secant of theta is equal to 4/5, and the last one is cosecant. Number 6. Theta equal to the hypotenuse divided by the opposite, which is equal to 5/3. So this is the idea of how to find the sixth trigonometric function if you are given two sides of the right triangle. Take another one. Suppose that you are given this right triangle, and this is theta, but one of the two sides, opposite or adjacent, is not given. Suppose that what's missing is the opposite, for example, and you are given 12 for the adjacent and 13 for the hypotenuse. Now what is missing from this one is the opposite. So to find the sixth trigonometric function, I have to find the opposite or the other three trigonometric function, because I can find the cosine and secant. The other four, I cannot find them unless I have the opposite. Now using the Pythagorean theorem, we'll have opposite equal to square root of, from the last example, we said that the hypotenuse equal to the square root of opposite square plus adjacent square. Now, if the missing is the opposite, this is the missing, then we will have hypotenuse square, but this time it is minus. Hypotenuse square minus the adjacent square. So we can say that if we need to find the hypotenuse, we will add the square of the two sides. But if the missing is one of the two sides of the right angle, then it will be square root of the hypotenuse square minus the other side. This is equal to 13 square minus 12 square, which is equal to 169 minus 144. It will be square root of 25, which is equal to 5. So the opposite is equal to 5. Now, this is the opposite to the given angle, theta. Now we can find the sixth trigonometric function. Number 1, sine theta equal to the opposite divided by hypotenuse, which is equal to 5/13. Number 2, cosine theta, which is equal to adjacent divided by the hypotenuse. That will be 12/13. Number 3, tangent. Tangent theta equal to the opposite divided by adjacent, which is equal to 5/12. Number 4, cotangent. The opposite of the tangent, that will be adjacent over the opposite, which is equal to 12/5. Number 5, secant theta, which is equal to the hypotenuse over the adjacent. This will give me 13/12, and number 6, cosecant, which is equal to the hypotenuse divided by opposite. That will be 13/5. So these are the 6 trigonometric functions. Let's have one more example. Number 3. Suppose that you are given, let's say example number 3. And this time theta will be up. And suppose that you are given 4 and 3. What's missing from this example is the adjacent, because this is now is the opposite. This is opposite. This is adjacent. And this is, as usual, the hypotenuse. Now the missing is the adjacent. So we need to find the adjacent first. Equals the square root of hypotenuse square minus the opposite square, which is equal to 4 square minus 3 square. It will be square root of 16 minus 9 equals square root of 7. Now this is the adjacent now. So we have to be careful about the location of the given angle, theta. Is it down or up? If it is up, just look for the side that will be opposite to that one. What is close to that one is the adjacent. So this is the adjacent. Now we can find the 6 trigonometric functions. Number 1. Sine theta. It is the opposite, again, divided by the hypotenuse. Which is equal to, opposite is given by 3. Hypotenuse is equal to 4. Number 2, cosine theta is the adjacent divided by the hypotenuse, which is equal to square root of 7 divided by 4. Number 3, tangent. That is the opposite divided by the adjacent, which is equal to, opposite is 3, adjacent is equal square root of 7, and I can find directly the cotangent. Cotangent is the opposite of the tangent. So it is equal to square root of 7 divided by 3. It's the opposite of the tangent. Number 5, secant of theta, which is equal to, it's the opposite of cosine, it is the hypotenuse divided by the adjacent, which is equal to 4 divided by square root of 7. But in general, if we have square root in the denominator, we need to sometimes to rationalize it. This is 4 square root of 7 up divided by 7 down. Same thing, I can write this one as 3 square root of 7 divided by 7. We call this rationalizing the denominator. Number 6, the cosecant is equal to the hypotenuse divided by the opposite, which is equal to 4/3. These are the 6 trigonometric functions. And these are applied for the right triangles. We have angle with angle equal to 90, then we can apply the 6 trigonometric functions. Opposite divided by the hypotenuse or by the adjacent will give me different type of trigonometric functions: sine or cosine, tangent, cotangent, secant, and cosecant. Later on, we are going to find some trigonometric function for special angles, or how to find exact values for some given expression.